Hi, we're going to start Sig Figs. Okay, we are going to be talking about Sig Figs today and the rules for counting Sig Figs. After we understand how to count Sig Figs, then we're going to apply those rules to learn how to round numbers. After this tutorial, if it is successful, you will never have to ask again how far you round a number. Isn't that exciting? Okay, rule number 1 says if the number is not a 0, then you're going to count it as a sig fig. And I have 3 examples here, and you can see that in every single example, all the numbers are significant. In 55, there are 2 sig figs there. Rule number 2, zeros are where you're going to have problems in counting sig figs. Zeros that appear between 2 non-zero digits are significant. So see, this 0 is between 3 and 4. 3 and 4 are count, so that 0 is significant. There are 5 sig figs right here. 404, 3 sig figs. This 0 counts and this 0 counts because both of them are between non-zero digits. So all of these numbers here are significant. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 sig figs in that number. Now, rule number 3 is where it starts to get a little fuzzy. A 0 is not significant if it is a placeholder. And after you do a few of these, you'll start to understand what I mean by placeholder. In the number 7,000, 7 is significant. These 3 zeros are not significant. Now, they are important. Certainly they're important. 7 is a very different number from 7,000. But we do not count them as significant. So this number has 1 significant digit. In 450, there are 2 sig figs. This is just a placeholder. Then we also have placeholders in numbers that are smaller than 1. All of these zeros are placeholders. So they are not significant. Important, yes, but not significant. Here you have 1 sig fig. Okay. Rule number 4 says zeros at the end of a number and to the right of a decimal are always significant. And that's because they've actually been measured out that far. So here, this 0 is significant because it's between 2 non-zero digits. There's 4 sig figs there. This 0 is not significant because it's just a placeholder. There's no decimal there. Okay? So there's only 2 sig figs. And here, this 0 is significant because it is at the end of the number to the right of the decimal. This 0 is significant because it's between 2 significant numbers. And this 0 is significant because it's between 2 significant numbers. So this has 1, 2, 3, 4, 5 sig figs. Zeros are tricky. The zeros are the tricky part with sig figs. If it's a trailing 0, and that means it's a 0 at the end of a number, okay? It is not significant if it's to the left of an implied decimal. Now that decimal point will not be there. Otherwise it would be count as significant. If it's a trailing decimal and to the right, this is misspoken. If it's a trailing 0 and it's to the right of the decimal, then it is significant. So here in 40, the number 40, there's 1 sig fig. In 4.0, this is a trailing 0 to the right of the decimals. There's 2 sig figs. This is a trailing 0 to the right of the decimal. 1, 2, 3, 4 sig figs. Okay. And then rule 5 says counting numbers and conversion factors have unlimited sig figs. So if you're counting something like ball players or fingers or students in a classroom, you can't have partial numbers of those. So they have what we say is unlimited sig figs. And conversion factors are the same. You have 1 meter is equal to 100 centimeters, unlimited sig figs in these kinds of numbers. All right, so let's practice here. And I give you the answers on the next slide, but we're going to talk about the answers here. This has 2 sig figs. This is a trailing 0, no decimal, so it does not count. It's a placeholder. trailing 0, but it counts because it's to the right of the decimal. 1, 2, 3, 4, 5. Here, all of these are trailing zeros to the right of a decimal. 1, 2, 3, 4. You have 1, 2, 3, 4 sig figs. You just, ignore that for counting sig figs. Here, all non-zero digits, 1, 2, 3, 4, 5, 6 sig figs. Here, this is a trailing 0 to the right of the decimal. It counts. The 5 counts, but that's it. There's only 2 sig figs there. All of these are just placeholders. Okay, so here's the answer. And then I'm going to give you a shortcut. This is a little trick, and it's called the Atlantic-Pacific rule. And I put a map in there so that, in case you forgot, the Atlantic is on the right side of the United States and the Pacific is on the left. Okay, so the Atlantic rule says if the number has no decimal, there's no decimals in it, then start on the Atlantic side. So see that blue arrow, this blue arrow here starting on the Atlantic side. Once you hit the first non-zero digit, count and keep counting. So this would be 1, 2 sig figs. Okay, so if the decimal is absent, get it A, absent, A, Atlantic, start on the Atlantic side. The Pacific rule says if the number has a decimal present, P present, then start on the Pacific side of the number. And once you hit the first non-zero digit, start counting. So 1, 2, 3, and you keep counting till the end. These are just placeholders, but this is a little shortcut that might help you. Okay, now that we know how to count sig figs, let's use them in our calculations. That's the purpose of sig figs anyway, to determine how to round a number for an answer. So the first, we have 2 rules. One is adding and subtracting, and the other is for multiplying and dividing. So let's look at the adding and subtracting rule first. And this says when adding or subtracting, use the same number throughout the problem, and then round to the lowest decimal point the problem started out with. Now what that means is if you have 2.34 here plus 5.1, this goes to the hundredths place, this only goes to the tenth. So you just go ahead and add those, you get 5.44. And then since this only goes to the tenth, you round your answer to the tenth, 5.4. Another example, this number you can see goes out to the thousandths place. And this number goes to the hundredths thousandths place. So after you've subtracted them, this is your answer, you're going to round it to the thousandths place because that's the lowest number of decimal places. I will always refer to that as rounding it to the least accurate place. Okay, I'll say, well, what's your least accurate number? If it only gets rounded to the tens, then round it to the tens. If it's the ones, then round it to the ones. Okay, but you always round it to the least accurate place. When you multiply or divide, you again do the same number throughout the problem, and then you're going to round to the lowest sig fig the problem started out with. So if you are given 45.01 times 4.8, this has 4 sig figs, this number has 2. So when you get ready to round your answer, you're going to round it to 2 sig figs. In this case, it would be 220. Now notice, I've got to put that 0 there because that's a placeholder and it's important, but it's not significant. So this number still has 2 sig figs. Another way to do this would be to put it into scientific notation, and you could make that 2.2 times 10 to the second, and then in your 2.2 is your 2 sig figs. This number has 4 sig figs. This number has 1. So when you round this, you're going to round the answer to 1 sig fig, which would be 5. Okay? And that is it.